Hello, my name is Ashish Valkyrie, and my project is the ICE programming language. To show you what it can do in the machine code generation, I'll first show you this very simple program. It generates a random number from 1 to 10,000, and this is how many coronavirus cases can be if the user presses A. So they only get to do it 2 times. So, if you look right here, I'm going to make this full screen. Here you'll be able to see there's some debug stuff here, but if you look, it's generating all this LLVM code. So if I input A, I get 8,350 coronavirus cases. If I put A again, I'll get another set, and then that's the end of the program. It's pretty basic. If I run it 3 times, I'll get to go 3 times. So you'll see. If I do A, and then A, now it closes. So we have a loop structure and an if structure here. Right, we have direct native machine code running for string comparisons, so we can actually do direct string comparisons from user input, and this is a pretty extensive section of the language. It can do these kind of things. So let me show you some other stuff. Let's do some basic expressions. So 12 times 2 divided by 2, something like very simple, like so. So I'm going to print A, right, and we get 12. Obviously 12 times 1 is that. So if I did something maybe like 4 divided by 2, you'll see maybe 20 get 24 now. So it does have the order of operations and everything like that working out properly. Not only that, it does have error checking. It's a little bit whack from here to there sometimes, but you can see that it's expecting the value of a semicolon. So I put it back. Program runs as normal. Pretty nice. And so we have while loops, we have variables that we can initialize. There's a lot of very cool things. So let me show you. I'm gonna take in maybe user input. Hello. And we can print out Boolean statements as well, so you can see whether my input is hello or not. So I type in hello. The reason I get 0 is because I got a space here. So if I don't put a space, I just type in hello, I get 1, which is the correct input value in Boolean is 0 for false and 1 for true in usual low-level programming terms. For a quick explanation of the actual code that's going on here, a lot of debugging stuff going on. Here's the actual main IR generation. It's adding some internal functions like string comparisons, get input, random functions, stuff like that. And here it's reading the file, and here it's actually running the parser. For a quick explanation of how this actually runs, I'm going to show you the tokenizer C class. Here we have a bunch of arrays just for comparisons. We have a bunch of things to be interned using the string interning. So as you can see over here, you have different go-to statements for different sections. So here it goes to white space, identifier, line, string, floating point. All of these different things is what it's comparing to. I'm going to go briefly to the parser. The parser, like I said in my description, you'll see a little bit more in-depth explanation as to why I'm doing some stuff here. Here you'll be able to see this is the parser. It's looping through a bunch of AST pointer statements. So it's parse the while statement. I'm going to parse the print statement. And here's the main core of our code. This is going to be an AST.h. These are just the solid data structures. This is actually how I'm generating that input function in LLVM manually over here. And here's the big bulk of what's generating. This is about 500 lines currently. You can see I put some notes for myself. Over here, you can see how I'm resolving these things into different LLVM types that are being generated, right? And we have a bunch of checks that are being done here, like greater than or equal to, stuff like that. So another demonstration of some interesting things. You can have multiple branch if statements. So for example, if I have a equal to 2, I could say if a equals 2 and 1 equals 1, print hi. and make it high. Now if a equals 1, we don't get anything printed down. So this is all I wanted to show for the demo. It's a complete and executable JIT compiled programming language. To see how it's being called, you can see it's calling LLI, which is an actual JIT executable. And I also wanted to show my static library that I made called libmlh specifically for this MLH hackathon. And I wanted to show you, this is the C++ code behind the functions for string equals, string cat, well, not necessarily this one, but adding and getting pointer values in a set pair, and it's just being compiled to a static library. Thank you for watching.